Hello. In this section, we're still continuing our work on graphs, and in this one, we're going to look at reciprocal graphs. Okay. So we looked at polynomial graphs up to now, but now we're going to look at a different type of graph, reciprocal. So as a reminder, if you have a number x, right, its reciprocal is it's a fraction. It flips, right? So you can imagine this as x over 1. If we flip it, so we get the reciprocal, it will be 1 over x, okay? That is what we call a reciprocal function, okay? And that's what we're going to look at sketching, functions that look like this. Cool. Okay, so let's investigate this then. Um, let's have a look at firstly what happens. So we want to investigate what happens when x goes to infinity, right? That's generally what we like to do with graphs. Look at the long-term behavior. I talked about long-term behavior in the last video when I talked about quartic graphs. But essentially, what happens when x gets really, really large, and when x gets really, really small. So when x goes to infinity that way, positive infinity, and then on the other side when x goes to negative infinity. Anyway, so let's investigate that first. Um, let's pick some larger numbers for x. So let's start with 1 over 1,000. If you put that in a calculator, you would get um, well, actually, you get 10 to the minus 3. Okay, which is in standard form. Remember, we can convert that into um 0.001, right? So remember the decimal point is there, then you move 3 points because that's the number there, and that's how we deal with standard form, right? So that's the number we get, fairly smallish, right? Um, but then let's have a look when we have 1 over a million, right? Put that in a calculator, you're gonna get well, you're gonna get 10 to the minus 6. Uh, and um, and so that's gonna look like 0.00001. So that makes sense. 1, 2, 3, 4. Yep, cool. And as you can see, it's a lot smaller now. This is basically nothing at this point. And hopefully, what you realise is that as x gets really big, so the denominator, as x goes to infinity, we call it, hopefully you can see that the denominator, the overall result, the fraction, is going towards 0, isn't it? So we can say that goes to 0, okay? So what we eventually want to happen is, in our graph, it kind of wants to level out. So if we have, draw an axis there, x, y, we want our graph, basically in the long term, to kind of level off at 0, right? Um, However, it cannot ever be equal to 0 because infinity isn't an actual number, right? The same when x goes towards infinity. So you can get large, you can think of larger values of x, but there will always be a bigger number each time because there are infinite numbers, right? So infinity isn't actually a number we can put in or obtain, but we describe it as going towards it, right? And so as it's going towards this infinity, some really, really large number, then this fraction also goes towards 0, but it cannot be 0 because x cannot be infinity. And remember, like a real line, a number line, keeps going on forever, right? So with that in mind, it's not going to be 0, but it's going to try and go towards 0. That's what it wants to do. What we can say is that x well 0 is the origin, so um we would say, oh, it's a bit messy. Uh so it's gonna, so if we continue our axis like that, it's gonna slowly keep creeping towards the axis, right? But it's not ever going to touch the axis. So what we say is, when we have in general a function or a graph, when it's going towards a particular value but never touching it, we call that an asymptote. Okay. So an asymptote is a line which uh, a curve tends to, but never touches. Okay. And it's happening here, right? So it wants to go towards. Well, what would it be? The x-axis, remember, it's just y equals 0. So y0 would be the asymptote here. Okay. Because it wants to go towards 0, as we just discussed. As x gets bigger and bigger, it goes towards 0, but it can never be 0. Okay, so it wants to go towards 0, but it can't be. So that is an asymptote. Okay, so that's what we're going to bear in mind. Cool. Okay, but what about the other side then? What about when x gets negative infinity? So we have a really big number, but it's negative. Well, okay, let's pick some values again. Let's use the same ones. So, if we have them for say 1 over minus 1,000, that would be minus 10 to the. It's just going to be negative of all of this, isn't it? So it's going to be negative 0.001, and then 1 over negative a million is going to be negative 0.00001. And so again, it's a very similar effect, but it's kind of the opposite sign, right? So when we go towards negative infinity, when we go to the left, right, of the x-axis, so when we pick really big negative values, okay, then the opposite effect occurs. It wants to go towards 0 again, right? Right. Negative 0.001 is very, very close to 0. So it's going to have the same effect, but in reverse, right? So again, it's going to go towards 0, but it will never touch it. Okay. So again, y equals 0, but the asymptote there. Okay. Because it wants to go towards the x-axis, but it can never touch it. Okay. So then we would say, as x goes to negative infinity, 1 over x also goes towards 0. Okay. Cool. So that's what we call the long-term behavior. We kind of got a really good sort of idea of maybe what the function would look like. But what's the problem with this function? Well, it's actually not defined at x is 0. So x cannot be 0 here. Okay. So I think we should investigate what happens when it goes towards 0 as well. So now let's pick really, well, how are we going to get 0? How are we going to, what happens if we plug in 0? That's undefined. So then let's pick values of x that are really close to 0, okay? So let's start with 0.001. So we're kind of flipping it the other way around this time. So now let's pick a small decimal. What happens there? Put that in the calculator. You get 1,000. Then if you do 1 over 0.00001, that's going to get you a million. And again, hopefully, you notice the pattern that's going on here. It's going to go in reverse again to what we just looked at. So instead of going, instead of going when we pick really big values of x for the denominator, it goes to 0. Now we're picking really small values that's close to 0, and now they're getting really big numbers as a result. So we're going from 1,000, then if you pick even smaller numbers that are close to 0, you get a million. And hopefully, again, you're going to notice that as x tends to 0, uh, this right reciprocal fraction, well, that's going to get really big, and so that's going to go towards infinity. Okay, so again, on a sort of graph, infinity would look like it was going. Well, if it's going towards 0, the origin, well, it's going to shoot up, isn't it? It's going to keep shooting up forever. Okay, uh, but yeah, so okay, with that in mind, then we've got a really, really good idea of what the graph will look like. So let's sort of visualize it. So the key components is when x goes to 0, um, it needs to go to infinity. So either side of this, right, of the left and the right side of the y-axis. So here has to shoot towards infinity, and up here, uh, But hang on a minute. But what happens when x is negative? Well, the whole fraction would be negative as well, wouldn't it? Right? Because 1 over x, well, if x is positive, 1 over x is positive. If 1 over x is if x is negative, 1 over x is negative. So, we have to match the negativity with x. So if x is negative, 1 over x is negative, right? And vice versa, if x is positive, 1 over x is positive as well. So with that in mind then, so when x is positive, so let's focus on the positive x-axis first of all. So x goes there. Well, we know first it has to shoot up from 0, so it has to go to 0, so it's going to come down like this, right? And then we also discussed when x goes to positive infinity, when x gets really big, the fraction goes to 0. So it's going to start to level off at 0, okay? There we are, and it'll keep going like that forever, okay? Towards when it reaches the asymptote at y equals 0, right? So remember, our asymptote is y equals 0. And then the flip side then, so that's y-axis. So, um, oh, there we are. Okay, and then for the negative axis then, so when x goes to negative infinity. Well, firstly, again, if it's negative, as we discussed here, it also the reciprocal has to be negative as well. So it's going to have to go below the x-axis, right? Because that's where the negative values of y are, down here, right? So again, it's going to go to infinity. Well, actually, no, because it's going to go to negative infinity. Because if you think about 1 over, let's say we did the same values here, but if we did, say, minus 0.001, that'd be negative 1,000, right? And then if we did the same here, it'd be negative 1,000,000. So that negative sign actually means it's going towards negative infinity. So a negative are a really big number. So instead of positive infinity, when it's going upwards, it's going to go downwards. Okay. So with that in mind, it's going to instead on the left side, it's going to come through up here instead from negative infinity. And then again, it's going to go towards 0 as we discussed. What was it up here? When we picked really large negative values of x, we get it towards 0. Okay, as we saw here. There we are. So when x goes to negative infinity, the reciprocal, the fraction goes to 0. And therefore, that gives us our graph, right? Cool, with an asymptote at y equals 0. So in summary, our graph here of the y 1 over x um, is going to look like that, okay? Here we are, and here we are, okay? Cool. So that'll be y equals 1 over x. Okay, cool. And in general, when with graph sketching at that point, it's a good idea, as we discussed, to see what happens when it goes to infinity, and negative infinity either side, but also what happens with negative values of x as well, like we saw here. So negative is as we saw here, when x goes to 0, if it's positive, so if it's going from 0.001 to 0.0001, but it's still positive, right? We get a really large positive number, right? But on the flip side, when we had negative 0.001, it gives us like negative 1,000,000, negative 1,000, right? If you had negatives and negatives here. So that gives us the idea of like infinity and negative infinity. So if it's on the right side here, it goes from positive infinity, right? So it goes downwards. But then if it's on the left side of x here, then it's going to negative infinity. Okay, because we get negative values, right? Anyway, so that's a reciprocal graph. Okay. But there's other graphs we need to consider relating to this. And actually, another graph is what happens when y is 1 over x squared instead. Okay. So actually, it's going to be very, very similar. It's going to follow the same sort of properties. similar properties, but notice x squared means it's a squared number, so it's always going to be positive. So what happens instead is it's never below the x-axis, right? Because you can't have a negative y value because, again, as the whole fraction has to be positive, as it's a square number. So what's happening instead is this basically goes up and matches the right side of the graph instead. So if we have x and y here, well, is the right side going to change? This part of the graph? No, because it's still positive. Nothing's changed there. Well, other than it might go to infinity a bit quicker because x squared is bigger than x, but the general shape is sort of the same, right? It's the same, right? To make it a bit clearer, there we are. But then the left side, when x is negative, well, if it's negative, it follows the same pattern. The negative of x is the same as positive of x, because if we plug in, say, if we had 1 over minus 10 all squared, you're going to 1 over 10 squared, it's the same thing. So the negative version of the graph should match the positive version because they're the same, because x squared, negative times negative is positive, in the same way positive times positive is positive. So anyway, it's going to match it, so it's going to be like that. Okay, there we are. Cool. So that is what the x squared graph will look like. Let me make it a bit clearer. Oh, there we are. There we are. So that's what our x squared graph will look like. Cool. Now there's actually two more different graphs we need to consider, and these are the negative versions. So what if we had y is minus 1 over x, firstly? So it's the negative of this. Um, but what you need to realise is, and we will look at this in detail later on, but I want to touch it now, and actually you should remember from GCSE. But in particular, if we have any function, I'm going to do it here, but I'm going to rub it out afterwards. If we had any function f of x, so y is f of x, oh, if we then said y is minus f of x instead, well, what happens in terms of the coordinates? So originally f of x is just xy, right? Happy. Then what are the coordinates looking like now? Well, it's going to be x and minus y, right? Because if we, well, think about it. If we have y is f of x, you just effectively times in both sides by minus 1. So minus y would equal minus f of x, hence the minus y coordinate. Which means if we do the negative of a function, so if we do the negative of this fraction instead, we're kind of making the y coordinates negative. So what would that look like then? If, and the x coordinates stay the same, so with that in mind, with our graph 1 over x up here, if we just take every part of the graph and make it a negative y coordinate, well, let's say this point here, for instance. Well, it's still going to have the same x value. So if you have x and y value there, right? You have the same x value, but the y value then will then become down here instead, right? Because it's say this is positive y here, this would then be negative y. Okay, so the new point would be there. Likewise, if we map this point, say there, it would then still the same x value, but it would then move downwards like this. And hopefully, then what you spot is if we then make the y coordinates negative, it kind of it's a reflection in the x-axis, right? Um, so we reflect this shape, this curve, in the x-axis to obtain the graph y is minus 1 over x. Because of the fact that we are taking the negative of the y coordinates, right, as we discussed down here, which means if we turn in positive y to negative y, right, so if we add like y again, say here, then negative y will be down here. And hopefully you spot it's just a reflection in the x-axis by doing so. So with that in mind then we can deal with this other part of the graph. Well, if it's negative y, again, it's going to flip, it's going to reflect in the x-axis, so it's going to look a bit like that, okay? And that's because, again, the y coordinates, well, this is negative y, right, in this case, say at this point there, but it's going to instead be positive y, so I'm going to have a positive y coordinate, so it's going to go up there, okay? So, negative 1 over x is just a reflection in the x-axis of the original graph of 1 over x because of the fact we are taking the y coordinates and making them negative, and if they're negative, then they become positive. Okay, and that's all we're doing there. Okay, and lastly, we can do the exact same sort of thing with minus 1 over x squared. Okay, so if we add what y is minus 1 over x squared, well, we're going to do the exact same principle. So with this graph here that we're drawing of positive 1 over x, minus 1 over x, so if we have it here, x and y, well, we need to reflect it in the x-axis to make the y coordinates negative. So the y value is negative, right, of the graph. So instead, it's going to go and look a bit like that. So if we reflect on the right side of the graph firstly, it's going to look like that. And then we could do the same for the left side there. So if we do it on the left part of the graph, it's going to look like that, right? With the idea that if it's shooting to positive infinity when it goes to 0, right? If it goes to positive infinity, he's then going to go to negative infinity when x is 0. So it's just a reflection in the x-axis. Cool. So that's our 4 graphs then. So in summary, to make this really clear, uh, there are 4 types of reciprocal graphs that you need to learn, but you can kind of work it out by considering certain values. What happens when x goes to infinity? What happens when x goes to negative infinity? What happens when x goes to 0, positive 0 when it's positive, and then x is 0 when it's negative? Um, and that really helps you guide what the graph will look like. But overall, our graph, firstly, 1 over x then, with all this in mind, uh, well, it's going to go from infinity, but when it's positive x, right, 1 over x goes from infinity when it's close to 0, then it's going to go to 0 when it goes to positive infinity. On the flip side, 1 over x is negative when x is negative, so it's going to go from negative infinity to 0 again. And so, yeah. So that's y is 1 over x. Then I'm going to alternatively draw down here negative 1 over x. So xy, we have negative 1 over x. So instead, it's going to flip and reflect in the x-axis because we have negative y coordinates. So if it's on the positive y-axis, it's then going to go down to the negative y-axis. So with that in mind, it's going to have that shape there. And this part up here is going to go upwards instead on the positive axis. It's going to go up there. Cool. And that'd be negative y over x. Then we have what y is 1 over x squared. So that's when every x value makes it positive because it's a square number. So that's going to look, if you draw it here. So again, the right side is going to be the same as 1 over x because it's positive. So nothing's really changed there. Still goes from infinity and then it goes to 0. Same there. But then because it's negative the same as positive this way around, because we have a square number, it's going to basically reflect it like and match the shape because it's the same sign either way. And then lastly, minus 1 over x squared. Well, then it's the same idea of reflecting under the x-axis. So in this case, we're going to get, we draw our axis. Right, it's going to go again from infinity, and then it's going to go down like that. Oh, a bit clearer. There we are. And then it's going to do the same on the left side. So it's going to look like that. There we are. Cool. So those are the four graphs then, right? So now we have some questions. Not many, but yeah, I can get rid of this now because I've drawn it. But yeah, there's some questions. Basically, just basically you need to remember what the shape is, or ideally have a good idea of how you know what it looks like. Anyway, so they're asking us to sketch these graphs. So firstly, y is 4 over x and y is 12 over x. Well, obviously they're not 1 over x because we have 4 and 12, but they're the same idea, right? It's a multiple of 1 over x. It's the same sort of shape. Okay, so if we know what 1 over x looks like, we can plot these as well. So, firstly, 4 over x, again, it's 1 over x pretty much. So remember 1 over x goes at 0, it's infinity. So it comes up and then it goes back down and then it goes to 0, remember? And then on the flip side, when it's negative, it goes from negative infinity to 0. Cool. Oh, it's just not meant to be that bendy. There we are. Cool. So that is 4 over x. Now 12 over x. It said to sketch on the same graph. Now, just think about it. If we multiply 1 over x by a bigger number, so say 12 compared to 4, well, you can't. Every value is going to get bigger, right? So all you're doing there by multiplying by a bigger number. So 1 over x times 12 compared to 1 over x times 4 is basically the graph kind of sticks out more like that, right? So it kind of sticks out more like that, which means basically saying, as you can see here, say if you pick this x value here, right then, well, at the same x value, the graph 4 over x has a smaller y value than the corresponding graph at 12 over x, which makes sense because you're multiplying by a bigger number, which means I'd expect bigger values. Okay. So that's all essentially, and it's the same idea with there. Okay, so that'll then be y is 12 over x. So make that clear. Y is 4 over x. Then that is y is 12 over x. So when you have multiples, if you have two different multiples, the bigger multiple means the graph kind of is out more. If you get what I mean, as in that scenario there. So that's part A. Part B then is y is minus 1 over x and y is minus 3 over x. Again, that's the first one is literally just a graph of minus 1 over x. So again, that's just reflecting 1 over x in the x-axis because we're making the y values flip sign, okay? Because the y coordinates become negative. Anyway, so with that in mind, so 1 over x, well, 1 over x will look like this. So if we're going to reflect it, it's going to go like that, okay? Cool. And then flip side, it used to look like this on the negative, right? Now it's going to look like that. So that'll be the simple graph minus y is minus 1 over x. Then we have minus 3 over x, and the exact same idea. We have a bigger multiple. So we're doing 1 over x times 3. So again, it's going to kind of stick out more like that, okay? And there we are. So it's a bit awkward to make you be able to distinguish the two graphs because they're quite close to each other. But this is 3 over x here, and then I'd say this is minus 1 over x. That's where I'd label it. There we are. And then our last graph is y is 4 over x squared, and y is 10 over x squared. Also, again, we'll plot this on the same sort of graph. So firstly, x and y. But the key idea is forget the multiple. It's basically 1 over x squared, okay? And we know to plot that. So Again, the x squared means the side. Basically, it's 1 over x, but the sign is the same because the negative also become a positive. Well, if it's positive, it remains the same as 1 over x, right? But then 1 over x, but then the negative version, so negative x, well, negative x, well, negative x all squared, it's the same as x squared, right? Because again, negative times negative is a positive. So the negative side will also be the same. It will match to this. So it's going to look like that. Cool. I'll leave it there. So that we'll call that 4 over x squared. Okay. Again, then 10 over x squared. Again, that's a bigger multiple, so it's going to pull the graph. It's going to go outwards compared to the 4 over x squared graph. So it's going to look like that. Okay, on both sides. There we are. So then I'll call that y is 10 over x squared, the outer one, and then the inner one. If I move this, I'd say whatever is 4 over x squared. Cool. So yeah, they could throw you different multiples, but you just need to know the graphs, right? The 1 over x minus 1 over x, 1 over x squared, and minus 1 over x squared. Okay. Once you know that, you're golden. But yeah, cool. Okay, so that's the general gist, right? So we're going to leave off with an exam question then, not too much. So firstly, in this one, it's asking us to sketch the curve was k over x. Well, again, k is just a multiple. We really only care about y is 1 over x. But it says k is a positive, which means we strictly have y is positive 1 over x, okay? Obviously, 1 over x times k, basically, but k is a positive, so this will still be a positive graph. So we're just interested 1 over x. If it didn't say k was positive, it could be negative 1 over x or 1 over x, depending on what the sign of k was. So it would make our job harder, but in this case, we just told us k is positive, so we just have the 1 over x graph, the positive 1 over x. Anyway, so with that in mind, then, well, we're going to have that basically just sketch 1 over x. Because k multiples lots of that doesn't really change the shape at all. But yeah, so 1 over x again. Well, again, when it's positive values of x, so when x goes from 0 to infinity, well, at 0, as you see, explode goes up to infinity, so it's going down when x is bigger. Then when x goes to infinity, it goes towards 0. Then negative y, when x is negative, well, it's going to go from negative infinity, and then when x gets larger, when it goes to negative infinity, it will go to 0 as well. Of course, that's our 1 over x squared. We can just call that y is k over x, okay? It doesn't really matter. But yeah, that's the shape of it then, k over x. And then it says part B, hence or otherwise solve 16 over x is less than equal to 2. Now, there are two ways you can solve this, and we did look at an inequality exactly like this in the quadratic inequalities chapter. You could solve this by, well, treat it like an equation, right? If this was equal to 2, you would times by x, right, to get 16 into 2x and then go from there. But because we've got an inequality, x could be positive or negative, so it could flip the sign, right? Because obviously times by negative will flip the negative inequality. To get around that, you can just times by x squared instead, okay? Because x squared is a known positive number, right? So then 16x, right? Because x over x, 16x squared over x would just leave 16x. Then that would be then less than or equal to 2x squared. And then you could solve that as a quadratic inequality. However, they've given us this graph for a reason, okay? And hopefully you notice, right, 16 over x and k over x, well, that's just k equals 16, isn't it? Which means we can use our graph, pretty much. So let me get rid of this then. So 16 over x we basically have, we can call this graph, if k is 16, this will be the exact same graph of y 16 over x, right? And so we're saying this is less than or equal to 2. So what we want then basically is 16 over x to be less than 2. So the y value would be less than 2. Okay. Or equal to 2 actually. But yeah. So if we draw the line y equals 2, because remember, we can call these both like y curves, right? If this is f of x, right, and 2 is g of x, even though there's no x, right, we could say g of x is 2, but it just means we have 2 for every value of x, right? They're both they're both different graphs, so we can call that y is f of x and y is g of x. So if we plot the graph 2, that basically tells us we want the graph 16 over x, which obviously bear in mind we just have. We want that to be less than 2. So we want this graph to be less than this graph. So we want the curve 16 over x to be underneath the line y is 2. Remember when we looked at inequalities like this, f of x less than or equal to g of x in the last chapter? So what's it look like when one curve is underneath another? Okay, and that's exactly the same idea, right? This line y is 2. We're interested in when this curve, which we drawn again, is underneath the line, underneath 2, basically. And so yeah, so that's what it looks like if we draw this 2. So again, with that in mind, we want the curve to be under 2. So where is the curve under 2? Right? Without overcomplicating it anymore. So essentially, this means again we just want the graph to be underneath 2 or at least 2. So where's it underneath then? Because obviously it's less than or equal to, so it wants it to be underneath 2. Well, it's going to be this part of the graph, isn't it? Here, right? But also it's going to be this whole graph underneath here as well, right? Oh, this whole half of the graph down here, that's also underneath 2. Right? So it's these two regions, these two places of the graph where indeed it is less than or equal to 2. So what we want then to solve it is we want the x values, right, when this happens. So the x values of these two parts of the graph. Well, that's going to be this x value here, right? We don't know what that x value is, but when x is bigger than this value here, then it's underneath the graph 2, underneath the line 2. If it's bigger than x, well, the less than x, sorry, so we're going to the left side, left of it, well, it's going to be bigger than the curve, right? That's not what we want. Oh, that's not what I want either. There we are, drawing it again. So we want that intersection point, but also when x is negative here, right, on the negative x-axis, this whole graph is underneath 2 as well. So all x less than 0, why can't it be equal to 0? Because if x is equal to 0, remember the graph isn't defined because 1 over 0 is undefined, right? So x has to be strictly less than 0, which means it's the negative part of the graph. As we discussed, is all of it has to be less than 2. So that's the first part. Or we want x to be less than this number k. I'll call it k. No, we have k, sorry. I'm going to call this number n, right? We want this for this point of intersection, when x is bigger than this number n, right? As it goes bigger than n, then it's underneath, right? Oh, okay. Then it's underneath the graph, right? For values bigger than this intersection point. Okay. So then how do we find this intersection point then when it's underneath the line 2? Well, we equate them together, right? Remember, when two graphs cross or when two graphs equal each other, well, you just set them equal to each other. So 16 over x is equal to 2 at this point, right? This point n, okay? So then we solve it. Well, this is a very easy equation to solve because then we can say 16 is 2x if you multiply both sides by x. Then x is 8 if you divide by 2. So that's telling you this point is 8 when they both cross over. Which means then when x is bigger than 8, when x goes larger than 8, that means then it starts to go underneath the line, okay, which is what we want. That's the region we're interested in when this graph is less than 2. So overall then, if it's at 8, but then every value less than 8 is underneath the graph. So x would be greater than 8. However, um, it's actually uh, less than or equal to. So actually, it could also be 8 itself, right? And that makes sense because at 8, it's equal to 2 there. That's when the curve equals 2. And that's if it's less than or equal to 2, well, that means it can also be equal to 2. So therefore, x is less than or equal to 8. That corresponds obviously to that part of the graph. But also, we've got the other part of the graph when x is less than 0. Okay. Remember, so we could either have all x less than 0. So let's have one solution then. So those are the values of x where the graph is underneath 2. Cool. So that is and oh, that should be less. There we are, greater than or equal to that n. But obviously we know n is now 8. But yeah, that's reciprocal graphs then. Cool. So I'll see you next time.